All right, so hydrochloric acid synthesis. All right, so we're talking about parietal cells. So in the stomach lining, so like we have a cell here, whatever that cell is, and then now we have a parietal cell. Okay, so this is the parietal cell, and that's where hydrochloric acid synthesis occurs. Okay, so here we have our little blood. What do you want? Here's our little blood here. And you have to remember or recall this equation. And we've seen this before. So this is where we have carbon dioxide, and if you add water, you get carbonic acid, and that can be broken down into hydrogens and bicarbonate. Okay, so we're going to see that again. All right, so in the blood, you'll have CO2. And CO2 will come into the parietal cell. So CO2 comes into the parietal cell. The parietal cell has this enzyme in it, which you should know, carbonic anhydrase. So carbonic anhydrase is the enzyme that catalyzes this equation here, this process, a reaction, whatever. So we have our CO2 that came in, and we add some water, and through the carbonic anhydrase we get carbonic acid, and we can break that down into hydrogens and bicarbonate. Okay, and actually I'm going to do my little bicarbonate a different color. Okay, so now we have hydrogens and bicarbonate, and let's do hydrogen a different color too. Sorry. Let's just do that a different color. Hydrogens. Okay. So now we have hydrogens and we have bicarbonate. So hydrogen, or hydrochloric acid, is just hydrogen plus chloride, right? So we need to get some chloride. So chloride we get from the interstitial fluid. So chloride comes in, and we've got like a little sort of carrier that brings chloride in. But when we bring in a negative ion, we have to get rid of a negative ion. So when this happens, the bicarbonate leaves and goes into the blood. Okay, so we bring in a chloride, dump out a bicarbonate. Okay, the chloride, once it is in, it has a channel that it can go. It will go through this channel into the lumen of the stomach. Okay, so it goes into the lumen of the stomach through this channel, and then the hydrogen is then pumped out. There's a little like carrier thing here. So it's pumped out also into the lumen. But again, we've got this one positive hydrogen going out, so we have to bring in a positive ion. Kind of like a trade. So we bring in, what's the positive ion we can do? Potassium. And that is not a good color because you can't really see it. There we go. Okay, so we bring a potassium into the cell as we are exiting the hydrogen into the lumen. Okay, so once the hydrogen is in the lumen, it meets up with the chloride and it makes hydrochloric acid. So that's how hydrochloric acid is made. So this little carrier thing, it actually has a name. It is called the hydrogen potassium ATPase. So again, it is a pump. So we're pumping out the hydrogen. This is the hydrogen potassium ATPase. So this, again, this is a pump. I said that we're pumping the hydrogen. So that's what's causing that to happen. Once the potassium, just looking at the potassium there, once the potassium is in there, remember, potassium is always leaving the cell. So it will come back out its leaky channels back out into the lumen, or out into the lumen of the stomach. So we pump that potassium, and that's why we have to pump it, because we're pumping the hydrogen out into the lumen because we're pumping the potassium in, because of course there's more potassium inside the cell than out of the cell just normally. So that is how hydrochloric acid is created. So that is created there. Must have hydrochloric acid in the stomach. Why? Because hydrochloric acid, don't forget, hydrochloric acid plus pepsinogen equals pepsin, pepsinogen is just not active. So pepsin is the active form, and it breaks down proteins in the stomach. Okay? So that's why we must have hydrochloric acid. Okay, so that's all about that. So we will move on to the small intestine.